Welcome, everyone. The course Principles of Electric Circuits (PEC) will open the gate of the world of electricity for you. In Lecture 1, we'll answer 3 questions. What's the content of the course? What's the relationship between PEC and my other courses? And will it be an interesting course? After answering the 3 questions, we will guide you to the amazing journey of electric circuits. You may already have some other thoughts before learning the course. These thoughts may be like, I've studied the electric circuits in my middle school, so I've learned some basic electric circuit analysis. Then why should I learn it? And what's the relationship between PEC and my other courses? Because I think most students who choose a course may be major in EECS. The third question might be, is this course just an academic one? What's the relationship between my daily life and the course? We will answer the 3 questions in this lecture. Yes, you can solve questions like this. A simple question like this. You know the current must flow in this direction. This is a voltage source, this is a resistor, this is a resistor, and this is a switch. The current flows like this if the 4 elements connect in series. You can know that I is equal to US over the sum of Ri and RL when the switch turns on. This is a simple circuit, but there are many more complicated circuits in practical work. For the left circuit, you also know the current must flow in this direction. It must flow in this direction. It must flow in this direction. It must flow in this direction. And it must flow in this direction. There's no question for these considerations. But for the resistor R5, does the current flow in this direction or in this direction? You don't know. Use your knowledge learned from middle school. You cannot solve the current through R5, thus cannot know the voltage across R5. The right circuit looks more complicated. It has a new element, capacitor. The capacitor makes the analysis more complicated and also makes the circuit more powerful. Now we formally talk about the differences between the electric circuit course in university and the middle school. Firstly, in the university course, elements are various. Besides the resistors which you've learned, there are inductors, capacitors, diodes, MOSFETs, operational amplifiers, and other elements. What's more, our methods for circuit analysis are more enriched and more in general. These methods can help you analyze any complicated circuits. These methods include the node voltage method, the mesh current method, the superposition method, and the Thevenin theorem, and so on. Also, we not only teach you the methods of solving electric circuits in this course, but also tell you many other concepts, which are closely collected in many following courses, such as the concept of fault, pot, dual, quiescent operational point, and zero state, and so on. And the last, and may be the most important one, PEC may be the first course in your transition from the science courses to the engineering courses. Then we will introduce you many ideas. These ideas include the idea of engineering, the idea of equivalent, the idea of abstract, and so on. Whether these ideas can be built quickly in the engineering courses directly decide whether you can master the following engineering courses smoothly. Then I'll talk about the position of electric circuits in the whole course's structure of EE and CS. After you finish the electric circuits, you may learn 3 important courses. They are signals and systems, analog electronics, and digital electronics. The 4 courses are basic courses of EECS. After finishing these courses, students majoring in different directions may have different elective courses. For example, students who focus on high power may learn power electronics. Students who focus on high frequency may learn communication, and students who focus on IC may learn microelectronics. These 3 courses are called specific courses or specific basic courses. On the foundation of the 7 courses, we can begin learning a lot of different fields of courses. For example, if you are interested in energy processing, you can learn a series of courses on power system. If you are interested in signal processing, you can learn a series of courses on signal processing, control, communication, and computer. And these research fields are combined to build the ubiquitous IT and power. So all these courses belongs to application courses. From this picture, we can see that PEC is the core of all ECS courses and worth our high attention. Then I'll use several words to simplify describe the basic characteristics of electric circuits. First, electric circuits consist of several basic elements. Let's look at the three electric circuits. Don't be scared. The function and the analysis of these circuits will be taught clearly in our PEC course. They include the basic elements such as sources, resistors, operational amplifiers, MOSFETs, inductors, and diodes. And they all have the ability of energy processing and signal processing. For example, the left circuit is a subtracting circuit. The middle one is a NAND gate circuit. The right one is a buck chopper circuit. They have very important practical value in signal processing and energy processing. Thirdly, circuits can be analyzed systematically. We'll teach you many systematic analysis methods which enable you to analyze a circuit with any complexity. Fourthly, circuits can be designed with new functions. For example, for a buck chopper circuit, we can set up different value of the inductor to provide different value of voltage across the load. For a subtracting circuit, we can choose different value of R1 and RF to change the multiply coefficient of the result of U1 minus U2. They are the four characteristics of electric circuits.